Okay, distinguished guests, ladies and gentlemen, welcome to HKAES TechTalk, co-organized by HKAES and Hong Kong Engineering. I organized together with Professor Alfonso Ang. So at HK Engineering, we have conducted a weekly Tech Talk to share our scholar work to people of different disciplines. So to promote latest science, technology, innovation, HKAES received support from ITC to conduct HKAES Tech Talk. So today we are very delighted to have Professor P.W. Chan, Director of Hong Kong Observatory, to give us the fourth HKAES Tech Talk on living with extreme climates. 5 other talks will be conducted by June this year. There will be more the year after. So Professor Chan joined HKO in 1994 as a scientific officer. He has a special interest with our international airport. He has been there for a long time to look after research and operation in terms of low-level wind shear, turbulence, and weather monitoring and prediction. And so we thank him for safe flights and arrival and departure. So in 2019, he became the assistant director looking after weather forecasting and warning services, climate change research, and corporate communication. And of course, in year 2023, he became the director. He currently chairs meteorology subgroup for the International Civil Aviation Organization in the Asia-Pacific region. He's also vice chair of WMO steering committee on measurement instrumentation and traceability. And he, like our academics, he published more than 300 papers, and mostly on instruments and measurement. Importantly, he's a adjunct professor of Hong Kong U Engineering. Thank you to you. So ladies and gentlemen, we welcome Professor P.W. Chan for the talk.
So testing. Maybe it's not, is it working? Is it working? Okay. Thank you very much indeed. So this afternoon to see all of you to come to this talk about climate extremes. And this talk is of particular interest to me, and also of particular importance to me. First of all, of course, just what as some attendees said, today we really feel the extreme weather, so that global warming is working in a sense that the average temperature is rising, but still within this rising trend, generally rising trend of the temperature, there can be situations with a sudden drop of the temperature, so that we can still have some extreme cold situation. And then this year actually is the first time that we get to this level of very cold, which is defined as 7 degrees or lower at the Hong Kong Observatory headquarters, since the very extreme cold weather last time in 2016. So that I told my colleagues earlier before the winter that because of my experience in the summertime, which I'm going to talk about later, and now I will expect that something like 2016 is going to happen again this winter. And then fortunately, it's still not falling ice. There's freezing at the mountain top, but not falling ice. So that this is actually what we may experience from time to time in the future in terms of climate change. And as for the last summer, in the summer 2023, actually, I took over, as Professor Lee mentioned, I took over the director of the Hong Kong Observatory in March. So within my first 6 months is sort of a probation. I'm to be tested whether is a suitable director, a competent director. And then within these 6 months, we have Saloa, the number 10 typhoon signal. We have the historical rainstorm. I'm going to talk about that later, which broke the record of the hourly rainfall at the Hong Kong Observatory headquarters. And also we have, of course, which is one of my the thing that I'm still feeling not so happy is about the Conino, the typhoon. And then we go through all three of them. And then, in fact, if you remember, probably you don't remember, in every March, we will issue the forecast for the next, for the coming summer, about the total rainfall and also about how many tropical cyclones are going to affect Hong Kong. And then at that time, we said that, well, last year, that is earlier in March in 2023, talking about the coming summer, we are going to have below, normal to below normal rainfall. It turned out that it is correct, except 2 days. The rainfall associated with the remnant of the typhoon, the historical rainstorm, together with the rainstorm after the El Nino. Just because of these 2 days, we have all the rainfall coming back, so that the total rainfall at the end of the whole year is above normal. So that our forecast is wrong. But it is true for most of the time, except 2 days. So, this is extreme weather. I think I finished the talk already. This is exactly what's happening in a situation of global climate change and then with extreme weather. But anyway, I'm in the next hour or so, I'm going to talk about the extreme weather in Hong Kong, about the past and the future about the extreme weather, and then also the climate risk management, and finally some concluding remarks. So that I think that this is probably you're very familiar with that. So normally the temperature or whatever, rainfall, whatever, is going to have a kind of a distribution like this. We are going to have two extremes, extreme cold and extreme warm, for example, in terms of the temperature. But we are talking about the climate change so that there is a kind of shift of the pattern of the whole thing, so that we are going to have more extremes on one side and less amount of extreme on the other side. Just taking as the temperature as an example. So that the extreme weather in Hong Kong, I'm going to go through the tropical cyclones, the rainstorms, the severe thunderstorms and squall lines. This thing, I think, and also extreme temperatures. As for the squall lines, about the severe thunderstorm, actually, there's something we are looking at. Still, it's not that conclusive, but then looks like we are really experiencing very strong gusts, very strong squalls associated with thunderstorms nowadays. And also the rainfall tend to be more and more localized. In the past, 30 years ago, and I was a forecaster at the Observatory, normally we don't see those very localized rainfall happening in a small place, and with the rainfall accumulating to very high level. But then right now there are more cases like this. But then the reason for that is still not very certain. Whether it is related to urbanization or whatever is still not so clear. So first of all, about the tropical cyclones, and then on average in the Western North Pacific, including the South China Sea, normally we have about 30 tropical cyclones occurring every year, even though last year in 2023, there's less than that number. But then the question is, even though the number, there can be year-to-year variability, to most of us, the most important thing is about how many of them are going to be very severe tropical cyclones that are going to affect us. So that you're very familiar with the impact of tropical cyclone to Hong Kong, about the high winds, about the storm surge, which is very important as we look back, for example, in 2018 about Mangkhut, super typhoon Mangkhut, about the heavy rain and so and so. And in fact, before the typhoon is coming, also there can be extremely high temperature. And then now in the last 20 years or so, many of the extremely high temperature situations are associated with the subsidence at the outer circulation of the tropical cyclones. So that the tropical cyclone itself not just bringing to us very poor weather, very high winds or high storm surge when it really comes to Hong Kong, but before that, we also experience extreme weather as well. So that in the historical sense, actually, before we have the tropical cyclone warning signal, they're also dating back to 19th century. There are also some typhoons coming very close to Hong Kong, as you can see. Most of them are crossing the Luzon Strait all the way to the western coast of Guangdong, just to the west of Hong Kong. This is the most damaging flight path so that we may not experience direct heat. But then if you shift a little bit to the west, actually it's bringing very strong winds and also the storm surge to Hong Kong. As you can see, over the years, there's some variability about the higher level of the storm surge that can cause to Hong Kong. The Mankud, this is our recent example, is talking about the storm surge or the sea level at the Coral Bay that station in the Victoria Harbour. And then recent years, Mankud is the highest. But if you look back, all the way back to the, with some historical records in 1874, when we tried to recover the record from the newspapers, from the books written by the people at that time. In fact, that sea level may get up to nearly 5 meters. So that that kind of situation may happen again if we are going to have even higher sea level because of climate change. So probably you are familiar with that for Super Typhoon Hato and Mankud, the damage, and also both of them are not exactly over Hong Kong, but a sort of position just to the west of Hong Kong near Macau. And then this is the most damaging path that can bring about strong winds and also the high storm surges in Hong Kong. And since these tropical cyclones occurred near Hong Kong, and then that caused significant damage to us. And then we worked with quite a number of organizations trying to calculate the damage that the tropical cyclones can bring to us, so that there's a summary about the estimated economic cost. Actually, we are talking about the most significant one is Mankud, talking about 4.6 billion Hong Kong dollars, the total economic cost. And this is something in the past. And then no one expected in 2023, which is going to happen, what is going to happen again. And then that's the Super Typhoon Saloa. And then this one actually, if you can see from the track of the tropical cyclone itself, it's not very steady, even though it's looks like it's close to the one for Hato and Mankud, but in fact they're slightly different. So first of all, actually, the Saloa is affected by another tropical cyclone to the east over the western North Pacific. So that at first it's forecast to hit the eastern coast of Guangdong, so that the impact was not expected to be so strong. But the models, the numerical models, fail to capture well the interaction between these two tropical cyclones. That is the one Saloa together with another one, which is HKAES over the western North Pacific, and then eventually they're not going to interact with each other, and then the Saloa go all the way towards Hong Kong, and then bring the very strong winds. And then, so as you can see, we really have hurricane winds and a number of stations over Hong Kong, and also the sea level is very high. So that in terms of damage, of course, it's less than that of Mankud, but still, just within a few years, we have another super typhoon coming all the way to affect us. And then second thing about the rainstorms. So this year we have, because of the remnant of HKAES, we have the very heavy rain in Hong Kong, and then it broke a number of records. You can see at the Observatory headquarters, the hourly rainfall, 2-hour rainfall, and also the 6-hour rainfall, 12 hours rainfall, all the way. Basically, many records have been broken just because of this very heavy rain. And so this year, so you can see, because the heavy rain caused the landslides and also the serious flooding over the streets. And then we are very lucky for this case. That is really very lucky that the heavy rain occurred in the overnight period. It's not occurring in the daytime. If that kind of thing really happening in the daytime, when the people are still or on the way to work or the way to school, or staying behind the office, staying behind the schools, and then while the heavy rain is occurring, then the impact will be much larger. So that we have to get prepared for that. If we are going to have a prolonged rainfall, prolonged heavy rain, or prolonged rainstorm in the daytime, that will be really very, very damaging impact on the damaging effect on the local people. As you can see, actually, there's a remnant of the tropical cyclones to the northwest of us, and then all the way there's a curved band, outer curved band of rainfall, of heavy rain just over us. And then, as you can see from the rainfall distribution, it's very narrow, just over the central part of Hong Kong. And then, as you still remember from the news, the highest impact is on the southern Hong Kong, Hong Shan Bundao, all the way, all the shores wash out, and also the Wong Tai Sin, and then there's a flooding in the MTR station, and also the underground shopping arcade. So that, but then the rainfall distribution is very uneven. As you can see, Hong Kong is already so small, but then this kind of rainfall pattern is very difficult to capture. That's why we have been asked to provide an earlier alert about the occurrence of historical rainstorm, or at least a heavy rainfall over Hong Kong is so difficult because this kind of scale still not yet captured by the existing forecasting tools, just like the numerical weather prediction models. So as you can see, there's actually the 2 peaks of the rainfall, and then as I just mentioned, it's so lucky that the heaviest rain occurred just over in the overnight period. If this peak of the rainfall is occurring in the daytime, and then all the way the water rushing all the way down the stairs of the MTR underground MTR station, and we expect that that will cause a serious injury, or even cause the death, quite a number of deaths for those people maybe waiting for MTR in the underground stations. So that another peak of heavy rainfall occurring in the early morning. But then because after that we already issued the black rainstorm warning, so that basically the city came to a halt, and then the impact of that one becomes relatively smaller. So another major impact on the weather in Hong Kong is the squall. This one is not so well noticed by the local people. In fact, that can be very damaging to the for example, to the terminals for the containers, and then also can cause the trees to be uplifted, and then basically it talks in a shape of a bow, and all the way coming across Hong Kong, and then bring the strong wind to us. And then it did cause some death. In the last couple of years, the situation when we have a very intense thunderstorms. Actually, the origin of this is very intense thunderstorms, and then in the form of a bow, and then all the way coming across Hong Kong in a very high speed. And also there's a very strong downdraft, very cold air coming down to the ground, and then spreading all the way out. And then it causes a very sudden pickup of the wind, just like this. Just within a few minutes, the wind comes to a very high level, and the instantaneous wind speed can come to the level of a tropical cyclone. So that the only thing is that it's not persistent. It's just happening over a short period of time. But it comes all of a sudden in a way, and also is unpredictable, basically given the very small scale of the system. So that there are really people, for example, in cyclone, the people go out to have water sports, and then suddenly the winds pick up, and then they cause the death of the people. And then so we are also trying to issue early warnings to the people to leave the water, and then to avoid the very strong wind to them. And of course, apart from very strong wind, that can also cause hail. So hailstorms also, even though it's not so frequent in Hong Kong, that can happen when we have a very small-scale system, again with a very small-scale thunderstorms, bringing very heavy rain to us and also cause hail to us. So probably you are familiar with that, about the extremely hot weather, as I mentioned, before the typhoon coming. And then we can have a very high temperature. So this year, in July, the Surrey is the the typhoon that's causing serious flooding in Beijing, and then before it comes all the way to the north, and when still over the western North Pacific, we have very high temperatures, and it's getting very close to the record set by the Super Typhoon Hato already. And then, basically, for the latest records, they're all related to tropical cyclones. And then for the more conventional, as we can say in the past, about the cause of the high temperature because of the region flow, and then actually it's not that frequent already nowadays. So mostly the high temperatures are set when the tropical cyclone coming close to us. So this is the usual pattern when we have tropical cyclones over the Luzon Strait, Taiwan, or near the Luzon, and then we have the outer circulation. First of all, is a substance causing the suppression of the uplifting of the air, and then also there's a weak northerly winds bringing the hot air from the inland areas towards the coast. Then we can have very high temperatures. And at the same time, as this is what's happening today. That is, we have less cold days. But we can have extremely cold weather. So this is a situation exactly that I just mentioned earlier on. So that back to 2016, we have that kind of freezing at the time ocean, and then that happened again to today. So there are a number of factors with the enhanced greenhouse effect. We can have higher temperatures. With the thermal expansion of the seawater and the melting of the snow, and then that's the sea level rise. And also the changes in atmospheric circulation, and then that causes the change in the pattern about the rainfall distribution. And in fact, there are some studies about the convection near the equator, when with the predictions or projections by the climate models, looks like the area of the convection becomes more narrow. But then the rainfall amount is the same. That means we have a smaller area receiving the same amount of, or even more amount of rainfall, so that the rainfall intensity becomes higher and higher. And then this is exactly what has been observed in this part of the world. While at the same time, because of here is the rising air near the equator in the subtropical to the tropical area, but in the mid-latitude area, there's the subsidence. And then so that we also see there are many situations with high temperatures which causes the hill fire in some parts in California, in Australia, things like that, when it's under the effect of the subsiding air. So that's the changes of the circulation of the whole world because of the climate change. And then this causes the rain precipitation pattern and also the temperature pattern to change. And then this is the impact of the global warming. So, on the whole, that's the observatory's headquarters. The temperature record basically is following the analysis data from the global center as well. Basically, the temperature is on the rise, and then so that I think last year in 2023 is getting up to 1.45 degrees already. So this one is old. Last year is getting to 1.45, about the pre-industrial level, so that it's getting to the getting close to the 1.5 degrees set by the Paris Agreement. And then so this is under the background of the global temperature change because of the climate change, because of the greenhouse effect, and also together with the urbanization effect, we have the climate change in Hong Kong. And in fact, we have a collaboration with Professor Lee about this, about the Kowloon, what's happening over this area, about the temperature distribution. And then, in the last year, we gradually built up more and more stations, and probably this is of interest to you. And then, for example, at the Tsim Sha Tsui area, there's the smart lamp post project of the OGO, and then unfortunately it stopped already, so that it's not going to expand more. but it's providing the very interesting observations about very dense observations of the urban areas over the Tsim Sha Tsui area or over the central. Unfortunately, in the last year when we got the highest temperatures in the summertime, the number of stations was still not getting to very high level, so that we did not have very comprehensive observations. But later in the year, we got more and more stations, and this is the highest temperature of the New Year's Eve in the 31st of December last year. So as you can see, that's the measurements at 2 p.m. And then the background wind is a little bit light, not the winds. So you can see because of the background wind and also because of the sea breeze, and then on the Hong Kong Island side, in the central area, there's the weaker northern winds, and also in the northern part of the urban areas of Tsim Sha Tsui, there's also weaker northern winds. At the same time, we have the sea breeze from all the way, from the west, from the south, and also from the east. And then looks like at those times when we have high temperatures in the region, we really have that kind of convergence of weak wind from all the directions, just over the central part of Tsim Sha Tsui area. So this summer, I think that we are going to collecting more and more data to see whether this kind of pattern is really occurring when we have high temperatures in the Tsim Sha Tsui area. So as I explained, the climate change, and then there's the extreme temperature, so that's the shift of the temperature pattern. And so in Hong Kong, the temperature is on the rise. The hot nights, which is defined as 28 degrees or more, the number of hot nights is rising. The number of extremely hot days is rising. So extremely hot days, we define that as at the observatory headquarters with a temperature of 35 degrees or higher. And in fact, in the past, it's very seldom. And then suddenly, 2022 is getting to very high level. And then so that we are going to have not just the very hot days, but extremely hot days also based on the rise. And if we compare that, the 30 years average in the recent 30 years with the previous one, for the hot nights, very hot days, and also extremely hot days, it has been rising for many, many times. So that that's the clear signature of both the background of the climate change and also the urbanization effect. And the annual mean temperature is also on the rise, and then so that in the projections for different scenario, the SSP 4.5 and 8.5, and then also in the end of the century, there's the change in the annual mean temperature, and also in the number of cold days, which is in blue, and also the number of hot nights, and also the very hot days. The signature will be very clear. That's based on the projections that we obtained from the global climate models. And for precipitation, it's more difficult because for the projection of the temperature, basically we can see the general trend, and then it's very clear. But then for the precipitation, the variability is much larger, so that it's more difficult to say about the general trend, about the precipitation intensity or the rainfall amount at a particular place. But the general trend is that the intensity, the amount of rainfall over a certain period of time is going to increase. If it rains, it's harder to rain, but if it rains, it pours, so that the tail, that area becomes more significant. And that is also what we can see over the years from 1880s up to last year, and then so that the record about the maximum rainfall intensity, hourly rainfall intensity over the observatory headquarters is basically on the rise. And then in the recent last 20 years or so, the speed of rise is much faster. And then this is also the signature consistent with the predictions from the climate models. And as I can see, as I just mentioned, the rainfall amount, the change may not be so easy to observe, but then if in terms of the maximum daily rainfall, and then it becomes much higher. It's getting up to 25% higher in the SSP 8.5 scenario. And for typhoons, and for also it's difficult to say. And what is more certain is about the change in the tropical cyclone intensity, and also the proportion of very intense tropical cyclones. And also the rainfall amount is also much larger. And most important is because of the sea level rise, and then the storm surge risk is much higher. So that this is what we observe from our actual records. And this is also consistent with the expectations from the numerical models for this part of the world. And so I just mentioned about the impact of the climate change on the weather, about the rising temperatures, and also about the rise in the sea level, and also the more intense tropical cyclones and more extreme rainfall, more extreme wind, and also the storm surge and the wave becomes much higher. And then so that in the future it's going to be a multi-hazard situation, and stronger winds, higher rainfall, more extreme rainfall, and then we have to take actions in order to mitigate the impact of this trend. And so there is going to be a multi-hazard, the heavy rain, storm surge, wind wave, and the sea level rise going to all become more extreme in the future. And it is a multi-hazard scenario. And as we can see from the situation of Vancouver. And so in order to address this risk, we have to look at the hazard itself, about the exposure, and also about the vulnerability. So one thing about the risk management is to identify the major hazards, and also to study the impact and try to look for the adaptation and also resilience of the strategies. And it's going to cover a number of areas. We have to collaborate with each other in order to address these issues. So that the observatory and in fact is in fact providing advice to the government, and also the whole government is addressing this issue. That's the Climate Action Plan in 2050. That's the carbon zero, the carbon neutrality objective, and that's on the one hand. On the other hand, there's also the adaptation method that's under the Climate Change Working Group on Infrastructure. That's actually a meeting of a group of people involving the observatory, providing the scientific advice, and also involving the Works Department to look at the impact of the climate change on the various aspects, on the drainage, on the landslide, the chance, on the impact on the buildings, on the structures, things like that. So an example is the blue-green drainage infrastructure. There's taken lead by the Drainage Services Department. So there's the implementation of the flood storage tank and also the bio-retention system. And basically there's an area for the people to collect the rainwater when the heavy rain comes, and then so that the water is stored in the flood storage tank. And also we provided a warning for this system as well, so that when there's localized rainfall affecting this area, and then we issue the warning for the people to move away from that position. Because flooding may occur. And also, that's interdepartmental joint effort, as we can see in the examples of super typhoon Saloa this year. So before that, before the occurrence of the tropical cyclone, that's the exercise taken by the various government departments to take care of the people at Taiyo, because the Taiyo is an area strongly affected by storm surge. And also before the typhoon comes, there's the relief work taken by the various government departments, and also before the typhoon comes, there's taken lead by the Chief Secretary in liaison with all the relevant government departments to get the early preparation for that. And another major topic is about public education, so that we have published books together with other government departments, outreach to the people to have a documentary about, a drama documentary about the climate change, about the work of the Observatory, and also that we produce some videos to tell the people about the impact of the climate change. So getting to the end. So learning from the past, we see that there's the extreme weather is already occurring. And then against that background, we are going to have a multi-hazard situation. We have a heat wave, we have heavy rain, and also stronger tropical cyclones, and also more intense rainfall, and also the sea level rise also lead to the more serious storm surge in tropical cyclone situations. In view of these changes, we have to work together to raise the public awareness about the impact of climate change, and also act collectively to mitigate the impacts. And then the government is taking all the actions on all these aspects. Okay, that's the end of our presentation. Thank you.